This is review of similarity and dilations. So we have the first question here. It says triangle ABC is similar to triangle XYZ, and XZ is 27 centimeters. So we're given a picture of ABC. Now remember, one of our strategies is to be able to stack our letters on top of each other. So if they say that this one and this one are similar, remember you can stack A, B, C on top of X, Y, Z. So that way you know which corresponding parts match up here. So angle A is the same as X, B is the same as Y, and C is the same as Z. Okay, so I'm going to actually just draw the other triangle next to this one. So I'm going to try to draw a similar triangle that looks like the one I have. And we're naming it A to B to C. So remember, we have to name it the exact same way. So this is X to Y to Z. Always double check and see if they match. So AX, you see the A and the X are in the same position. BY, so the B and the Y match up. And then CZ, C, and Z. So that way we know that they match. Now remember, when you make something smaller or bigger, like think of a little square, all of these angles are all 90-degree angles, right? If I make that square bigger, it doesn't really matter. All of these angles are still going to be 90 degrees. So when you have similar figures, when you make them smaller and bigger, angles are staying the same, which means these three angles inside this triangle are going to match exactly to these right here. So I'm going to go ahead and put all those in. And 60. So the angle measures stay the same. And just think of the square idea if you forget. Plus, if you made angles bigger, they wouldn't add up to be 180 inside anymore. So think about if I made all of these bigger or smaller, they wouldn't get 180 inside. So it doesn't really make sense. Okay, side lengths. Now we have an 8 and a 9 and a 5, but they give us some new information up here. They say XZ. So X to Z is 27. So this is 27. Now here's the deal. If you look at the corresponding parts, so you see this 9 has changed into a 27. So what has happened to the scale factor or multiplier in between here? So remember, it's always going to be multiplied by something or divided by something. So most of you could do 9 times what makes 27. So what did they do to the 9 to make it equal to 27? So you can just divide if you want, or most of you could probably figure out that it's times 3. So what they're doing from this triangle to this triangle is multiplying by 3. So we're going to multiply everything by 3 on the outside. So that means we're going to get 8 times 3 is 24, and 5 times 3 is 15. So it looks like we have all of our numbers that we need. So all of our angles stay the same, and all of our side lengths are multiplied or divided by the exact same thing. So 9 times 3 is 27, 5 times 3 is 15, and 8 times 3 is 24. So we have both of our triangles. And now we can go and answer our questions. So our questions say, what is YZ? Now remember, if it doesn't have the bar on top, that means measure of or length of YZ, or distance from Y to Z. So look at our picture. Where is YZ? YZ is this piece right here, right? And that is a 15. So we're going to be selecting A. That is 15. What is the measure of angle Y? So I have to go and find angle Y. Angle Y is up here. And that says 87 degrees. So we're going to select 87 degrees. And remember, they could ask you any numbers. So that's why I just drew it and filled in all my information. Did not take me very long, and that way it was easy for me to answer my questions. Okay, let's look at the second one. It says triangle A prime B prime C prime is created by dilating triangle ABC by a scale factor of 2. So it looks like we don't have this triangle even in our picture, right? But we do need a scale factor of 2. And remember, if the scale factor equals 2, that means all of the side lengths are times 2. So the shape is going to be twice as big as this one. Now, there's a couple ways we can do this. We could find all these points and multiply all of those coordinates by 2 to get our new triangle. That is one method. I'll show you an example. So if we take point A, which is right here, that is to the right 1 and up 5. So if I wanted to know what A prime was, all I have to do is multiply this by 2 and this by 2 to get my new point, which would be 2 comma 10. So over 2 up 10. So this would be my new A prime. So it's going to be twice as far, assuming that's a 10. I can't really read the numbers on this graph. It's blurry. So really, our triangle, after we do our points, is going to look something like this, twice as big, right? Now, so we can do all of our points and then get, we want to find the length of A prime, C prime. So we have to go between A prime and we'd have to get the C prime, right? And get those coordinates. And remember, you can do two things. You could do distance formula, or you can do Pythagorean theorem to find the distance between 2 points. Because clearly it's going to be between A and C is up here. So it's going to be a diagonal line, so we cannot count bubbles. Okay, so that is one method. Now, some people don't like to do all of these sides because if we know we're going to do just A to C, some people like to just do A to C and then times it by 2 because remember, this is going to be twice as long as this. So that's probably the fastest method. So I'm going to go ahead and try that method. I'm going to look at A to C and I'm going to find the distance between A and C. So remember, I can make a fake right triangle. I can just go up and over and make a fake right triangle and count these boxes because remember, horizontal and vertical, we can count those boxes. So if I look at my picture and going up, that is going to be 4 blocks. Remember, count bubbles, 1, 2, 3, 4. So that's a 4 blocks up. And then to the right, that's going to be 1, 2, 3, 4, 5, 6. It's going to be 6 blocks. So my little right triangle right here, I'm going to color him blue so you see him. Do you see my little right triangle here? If remember, I can call these guys A and B and C. Remember, C is going to be the hypotenuse. So remember, the Pythagorean theorem is A squared plus B squared equals C squared. Now I'm calling this 6 is going to be my A. I'm going to call this 4 my B because those are my 2 legs of my right triangle. And the C is the side I don't have, which is my hypotenuse. So I'm just going to still call him C squared. I'm going to do some math. That's 36 plus 16 equals C squared. 36 plus 16 is going to give me 52 equals C squared. I'm going to have to take the square root of both sides to get rid of that squared. And in my calculator, I'm going to get that C is approximately 7.21. Okay, so that's saying that this right here is 7.21. And that makes sense because this is a 4 and a 6 and then a 7.21. Hypotenuse is the longest side. That makes sense. Now, we don't want just the length of AC because the length from A to C equals 7.21 approximately, right? Now, I don't want that. I want the triangle A prime, B prime, C prime. You see the primes on this? Prime, prime. That means I want this big triangle here. And that triangle is a scale factor of 2, which means it's going to be twice as big. So I have to times this by 2 in order to get A prime C prime. So if I multiply 7.21 by 2, I'm going to get about 14.42. So the length of that is going to be 14.42. Now remember, you could have done this. Remember, see, I could have gotten this C. This C was negative 5, 1. The regular C was negative 5, 1. And so if I got my C prime, I'm going to multiply by scale factor of 2. So that's a negative 10, 2. So negative 10, 2. That's over here. So I could have done Pythagorean theorem or distance formula using these 2 points. You see from here, I could have just made my right triangle that looked like this out here and done the exact same thing. Now, obviously, I would not have had to multiply by 2 when I was done. I would have just gotten 14.42 as an answer. So there's a few ways to do that problem. And remember, you always could do distance formula, but if you remember when we did distance formula, there was a lot of sign errors on that. So Pythagorean theorem seems to have less chance of error if you remember how to do that. Okay, number 4. Given this equation, a dilation with the center at the origin. So if center is at the origin, scale factor of 3 is applied. What is my new equation? Okay, now the same thing goes here. So if I have a line, so this line that I'm talking about right here is in, oopsie, I shouldn't do that. This line right here is in slope-intercept form. So it already looks like y equals mx plus b. Now remember, if it didn't, I would have to manipulate this and move some stuff around till it looked like that. But when I look at that, I could already tell you that the m equals negative 4 and the b equals 6 because I could just pull them right out of this equation, right? Now that tells me that this line is on this graph. It has an intercept of 6. 1, 2, 3, 4, 5, 6. So that means it crosses here. It has a slope of negative 4 over 1. So that means it goes down 4, 1, 2, 3, 4, and over 1. So my line looks like this, if we remember from Algebra 1. Now remember, when you make something a scale factor of 3, now remember, the slant of something does not change when you make it bigger. Think of a picture that looks like a house. Okay, if I have this picture, if I make it bigger, do you see how the slants of all of these lines look the same? So this is still slanted like that. This is still slanted like that. The bottom is still slanted like this. So the slant of the lines don't change when you make something bigger. It would be kind of like if you made your face larger when you zoomed in and it got all distorted and crooked. It doesn't happen. So all of these slants stay exactly the same. That means the slope stays the same. So slope is always going to stay the same because that is the slant of a line, right? How it rises and runs. So the slope is going to stay the same. Now the b, where it crosses the y-axis, is going to change. So think about this picture of this house on a graph. So maybe 1, 2, 3, 4, 5, 6, 7. So maybe right now the y-intercept of this house is about right there. So it looks like the y-intercept might be at about 4, right? Now when I made it bigger, what happened to it? It got all the way up here at 4, 5, 6. This is up at 7. So when you make something bigger, the y-intercept changes. Not always higher, sometimes lower. So look at this y-intercept down here. Like it looks like down here, now obviously this graph is not drawn to scale, it looks like down here it crosses like at negative 2. But down here, look at how much it got lower. So it's definitely true that the y-intercept changes. So this y-intercept is definitely going to change. The y-intercept changes. It's going to go up or down. And it actually changes based on the scale factor. So what you do is you take this and you multiply it by the scale factor. Multiply it by the scale factor. So it's going to go bigger or smaller depending if you multiply by the scale factor. So what's going to happen is this 6 right here is going to have to be multiplied by a scale factor of 3. So we're going to do 6 times 3, and we're going to get 18. So when this line over here, when we multiply it by 3, it's going to go up higher, 3 times as high, basically. But the slope is going to stay the same. So what's going to happen is our new equation, when it says what is the equation of the line, it's still going to look like y equals mx plus b, right? Your m is going to stay the same, so it's still going to be -4. And your b is now going to be 18. So that means my equation of my new line is y equals -4x plus 18. Okay, I pasted a couple problems here for you. Let me scroll these down some so we have some more space. Okay, I've got 2 problems for you here. I got 2 number 5s for you. Okay, so let's take a look at this. We have triangle DFE and triangle ABC are similar or not similar. So we have 2 triangles over here. Now remember, there are 3 ways to prove triangles similar. So the 3 ways are angle, angle, similarity. Oops, that's supposed to be a similarity. There is SSS similarity, and there is side, angle, side similarity. So that means if you have 2 angles, and the rule for these, angles have to be congruent, but sides have to be proportional, which means to make proportional. And that means you can make fractions out of them that are even. Okay, so if I have 2 congruent angles, then they're similar. If I have 3 sides where I can make 3 fractions that are all equivalent, they're similar. Or if I have side, angle, side, and we know that this is true, that the sides have to be touching the angle just like they did with congruence. So that means you have a congruent angle, and then on either side of that congruent angle, you have sides that you can make fractions out of. So that's your similarity foldable in your notebook of the 3 different ways. So let's look at number 5 over here. So we have a picture of 2 triangles. Now clearly we see this is a 90, right? Because we have a box in there. We got this 55 and we've got this 35. Now right now those don't match. But what is true about the inside of a triangle? The inside has to be add up to 180. So the inside has to add up to 180 degrees. So we could do a little math on our calculator. 90 plus 35. What do we have so far? 90 plus 35. So far in here, we've got 125, right? Now remember, it's got to add up to be 180. So if I just do 180 minus 125, I'm going to get my last angle of 55 right here. And look, I don't even need to do it for this one over here. I don't have to do the math on this triangle because guess what? I see a match. I see that this 90 matches this 90. And I see this 55, it matches this 55. So that means I have 2 congruent angles right here. So that means these 2 triangles are similar by angle, angle. So to answer my question, I would go up here. I would say these triangles are similar. So I would circle A. And then the reason down here would be because I have angle, angle similarity. So sometimes they don't label everything, but use some things that you used to know before, you know, about congruent angles, like if you have vertical angles or adding up to 180 in a triangle, use some of those ideas. Okay, let's try this one over here. So it says triangle D are similar or not similar. So this is the same idea. So remember, these are our three options we have. So let's take a look at this picture over here. So we have, definitely we have a matching angle, right? So we have this 50 and 50. So we do have an A, right? We do have a congruent angle. So maybe we'll have angle, angle, or maybe we'll have side, angle, side. But if you look at this, we don't have any more angles. So probably this is off the table, right? We can't get two pairs of angles because we only have information about one of them. And they're not, these guys are not touching. We don't have vertical angles or anything like that. No little squares to tell us 90 nothing. So we're going to see if we can make fractions out of them. Now remember, you can take a look at these and match them up. A, B, C, so that's A, B, C is congruent to D, F, E. Okay, so let's see if we can match these up. So A and D match up to each other. So that's A. I'm going to paint color these. And D match up. B and F. B and F. Okay, so we already knew that because those were both 50. And C and E. C and E. Okay, so I just color coded them so I know which way they're matching. Because look, this I like to think about how they transform this shape. So it looks like they just reflected it over and slid it down and made it a different size. So it looks kind of like a reflection. So that means this D is matching up to this A. So that means that this side AB that I'm painting orange matches this side DF. AB matches DF. So even if you look right here, you see AB and DF. You see how they're in the same spot? So AB and DF match each other. So I'm going to put, I like to make a little code. I'm going to call this guy my left triangle and my right triangle. So I'm going to put left over right. Now, it doesn't matter what you pick, but I always make a code. So I'm going to put these matching orange pieces left over right. So that means 12 over 8. Now I just need to be consistent and match the other piece. So let's see what we have here. For the other piece, this bottom piece, C to B, C to B, that's this piece, matches F to E. So that's F to E. So these two gray pieces match each other. Once again, I have to stick to my left to right. So I have to put the 24 over the 16. Now, I just need to see if these are proportional. And there's a couple ways to do that. You can literally put this in your calculator, 12 divided by 8, 24 divided by 16, and see what you get. I'll do that method first. So 12 divided by 8 is 1.5. And 24 divided by 16, top always divided by the bottom, is also 1.5. So that means that these two sides are proportional. So we do have two proportional sides. Two sides. Okay, so we have an angle and two sides. So we probably have this side angle side. Now remember, the other method you could have done, if you didn't want to divide, you could have cross multiplied and see if they're equal to each other. So do 8 times 24 and see what you get, and 12 times 16 and see if you get it. If those are equal, then they're proportional also. So either way works for you. Okay, so we just need to double check. Is this angle touching both of these sides? If I look at my picture, you see the 50-degree angle? It is definitely touching the orange one and the gray one. See this 50? Definitely touching the orange one and the gray one. So that means that we do have side angle side. So we've got side angle side similarity. So these are similar by side angle side. Okay, triangle LMN is similar to triangle TUV. So I'm going to start by making sure that these pieces match. So LMN matches TUV. So the L and the T, L and T match, the M and U. And these obviously look like they're just sitting there all nice and pretty matched up for us. But I'm just going to double check. Sometimes they have them and they don't look exactly the same. So these are lined up. One of them is just scooted up and down. So that means that this orange side right here matches this side right here. Also that this pink side matches this pink side, and this blue bottom matches this blue bottom. Okay, so if we want to find out what the measure is, sometimes you could look at it and say, oh, they multiplied by this or they divided by this, and you could easily figure out the numbers. But you can also just set up some fractions. So I'm going to do top over bottom. That means I'm going to do my top triangle over bottom triangle. So this guy right here over this guy right here. So remember, you could do small over large. And the last one I did left over right or whatever. It doesn't really matter. I just make a code so that I don't get it mixed up. Okay, so I need to pick a piece off my top triangle. I'm going to pick this pink piece right here. That's a 10. Now, what does that match? The pink piece on the bottom one is 2.5. Has to be equal to. Now, I could say pick another piece off the top. I could pick the 15, but I don't have anything to match it here, so I'm not going to worry about the blue side. I'm going to go with the orange side because I'm trying to figure out the value of x, right? So that's the top triangle is the 9 over the bottom matching piece, corresponding piece is x. So I'm just going to solve this proportion. And remember, you could solve by cross multiplying and setting them equal to each other. That means I'm going to do 10 times x, which is 10x, is equal to 9 times 2.5. Check that on my calculator. 9 times 2.5 is 22.5. To solve this, I'm going to divide by 10, divide by 10. I'm going to get x is equal to 22.5 divided by 10 is 2.25. So it says that this is 2.25. Now that makes sense. I always like to put it on my picture and see if it makes sense. So this triangle is clearly a lot bigger than this one down here. And I'm not looking at the picture. I'm looking at these numbers. 10 dropped down to 2.5. So this 9 dropping down to 2.25, that seems like it makes a lot of sense, right? So I'm going to pick answer choice A. All right, this last one. So I don't have any picture. So it says if LMN is similar to RST, which of the following proportions must be true? So I'm going to start by drawing these babies exactly the same. So I'm going to do triangle LMN is similar to triangle, and I got to name it in the exact same order. So if I did LMN, I got to do RST. And remember, you could stack these up on top of each other and make sure that they match. Is the N and the T in the same spot? Whoopsie. N and the T in the same spot. Is the R and the L in the same spot? So I'm good. Okay, now I'm going to go check these. Remember, lots of proportions will be true. Lots of them will be true. What you have to do is make sure that they went in the exact same order so corresponding parts match. So I like to pick colors. So I'm going to pick orange to test this one out. So I'm going to think about the way we do this. I'm going to do LM, that's this piece, right? Over RS. So LM over RS. So far, it looks like it matches, right? Remember, I went from this left shape to this right shape, right? So LM to RS. Now, look what they do right here. They do TS. TS is over here. Do you see how already they're out of order? Because if they went LM to RS, they needed to start over here to go this way. So they did MN. So it looks like they have the parts, but it looks like this is upside down. They did not go in the same order. If this would have been the other way around, it would have been fine. Or if this one was the other way around, it would have matched this one. But right now, we do not match. Okay, let's try this one over here. So, NL, NL, RT. So that looks good so far. I went from the left one to the right one. And then I did ML. That's this piece. So what do you think they're going to have to check on this one in order for it to match? They better be saying RS. But what do? They say TS. So this is nope. So far we have 2 wrong. Let's check this one down here. I'm going to go blue. LN, that's this bottom. LN, RT, so they went matching piece. And then they did NM, so they're going from the correct triangle, and TS. So this one actually is good. Let's check the last one just for the heck of it. MN, that's this piece right here. RS. We have a problem already, don't we? These two do not correspond to each other, so we are not good, even just with this very first half of our proportion.